It turns out that our universe is far from a static place. Thanks to observations from very powerful ground-based telescopes and space telescopes like Hubble, we know our universe is seething with activity. Galaxies are swirling in a cosmic dance, breathtaking in its scope. With so many galaxies hurtling through the heavens, over 100 billion of them, all whirling around each other, pulled by their gravity, inside this cosmic maelstrom, many galaxies collide. Some of them come at each other with such force that they are forever altered and morphed by the encounter. Throughout its majestic lifetime, the Hubble Space Telescope has been providing us with unparalleled glimpses of cosmic collisions. In 2008, the Space Telescope Science Institute released this poster containing some of these moments from a variety of mergers seen in many parts of the cosmos. 59 individual images, each a snapshot of an instant in a galactic collision. How do we know these are glimpses of various moments in a several billion-year-long event? Here is a simulation that shows a complete galaxy collision over a timescale of 1.5 billion years. The two spiral galaxies in the simulation distort, twist, and merge together, and by rotating the images at different times and viewing angles throughout the simulation, we can match each epoch with a corresponding Hubble image. As they approach each other over a few 100 million years, galaxy trajectories become dictated by their shape and mass, guided by the laws of gravity. Over the course of another 200 million years, one galaxy buzzsaws through the other, slicing it through the middle. Amazingly, because of the distances between the stars in each galaxy, about 1 light year for every star, very few of the stars in these galaxies will actually hit each other. The individual stars in each galaxy will simply pass each other by, suffering no effects other than perhaps an altered galactic orbit. After 300 million years, tidal tails develop, streaming stars into the intergalactic void. Some of these stars will be flung out entirely, left to wander the universe without a galactic home. At this stage, the centers of the two galaxies are now bound, held together by gravity and pulling each other closer. As the centers coalesce, each galaxy is no longer distinct, and 1.5 billion years since their dance began, they have become one galaxy. It will take another few billion years for the tidal tails to return. Galaxy collisions are very common in the universe. Every large galaxy we see has collided with another galaxy at least once in the past 9 billion years. Smaller galaxies collide 3 times more often than large galaxies, and anywhere from 5 to 25% of all galaxies that were seen in the various Hubble deep fields were in the process of merging at the time they were taken. Collisions are an essential element in the life cycle of all galaxies, and our own home, the Milky Way, is not immune. We are on a collision course with a monster spiral called the Andromeda Galaxy, which contains some 1 trillion stars. What would that look like? Our galaxies will begin to crash together in a head-on collision about 4 billion years from now. The thin disk shapes of these spiral galaxies are strongly distorted and irrevocably transformed by the encounter. In around 6 billion years, the two galaxies will merge to form a single elliptical galaxy, and the tiny Triangulum Galaxy continues to orbit the merged pair, perched high above the chaos. We on Earth, if we're still around, will be treated to a galactic show unparalleled in human history. Here is the view 25,000 light years from the center of the Milky Way. This is our sky tonight, the bright belt of the Milky Way clearly visible. The Andromeda Galaxy still lies 2.5 million light years away and looks like a faint spindle, several times the diameter of the full moon. In around 2 billion years, the disk of the approaching Andromeda Galaxy is noticeably larger. Andromeda fills the field of view. The Milky Way begins to show distortion due to the tidal pull from Andromeda. During the first close approach, the sky is ablaze with new star formation, which is evident in a plethora of emission nebulae and young open star clusters. After its first close pass, Andromeda is tidally stretched out. The Milky Way also becomes warped. During the second close passage, the cores of the Milky Way and Andromeda appear as a pair of bright lobes. Star-forming nebulae are much less prominent now because the interstellar gas and dust has been significantly decreased by previous bursts of star formation. Finally, 7 billion years hence, the merged galaxies form a huge elliptical galaxy, its bright core dominating the nighttime sky. Scoured of dust and gas, the newly merged elliptical galaxy no longer makes stars, and no nebulae appear in our sky. The aging star population is no longer concentrated along a plane, but instead fills an ellipsoidal volume. The Milky Way and Andromeda galaxies are now one.